If vector v is equal to -2, 3 and vector u is equal to 4, 5, find the magnitude of the vector v plus u. Before we can find the magnitude of the vector v plus u, we first have to find the vector v plus u. So we will add the vector v to the vector u. Vector v plus u will be equal to the vector v, which has the components -2, 3, plus the vector u, which has the components 4, 5. We will add the x component of the vector v to the x component of the vector u, and then we will add the y component of the vector v to the y component of the vector u. So we will have -2 plus 4, which will give us 2, and 3 plus 5, which will give us 8. So the vector v plus u will give us 2, 8. To get the magnitude of a vector, you have to take the positive square root of the sum of the squares of the x component and the y component. So here, the magnitude of the vector v plus u will be equal to the positive square root of the x component squared, so we have 2 squared, plus the y component squared, so we have 8 squared. So the magnitude of the vector v plus u is equal to the square root of 2 squared plus 8 squared. Square root of 2 squared plus 8 squared will give us square root of 68. And when we simplify this, we will have the magnitude of the vector v plus u as 2 root 17. If the vector OP is equal to 8, -9, and the vector OQ is equal to 3, 5, find the vector PQ. The vector PQ is given by the position vector of Q, which is the vector OQ, minus the position vector of P, which is the vector OP. We have both the vector OQ and the vector OP, so you will substitute them here. When we do that, we are going to have 3, 5 minus 8, -9. 3 minus 8 will give us -5, and 5 minus -9 will give us 14. So the vector PQ is equal to -5, 14. Vector PQ is equal to 2, 4. Vector RQ is equal to -1, 5. Find vector PR. This is a multiple choice question, and so we will solve the question, and then after that we will pick the correct option. The 3 points here are point P, point Q, and point R. Let's assume that these 3 points are in the same plane. We have point P here, point Q here, and point R here. The question says that we should find the vector PR. So we are looking for this vector, the vector PR. As we can see from the diagram, moving from P to R will be equal to moving from P to Q, and then moving from Q to R. So the vector PR is equal to the vector PQ plus the vector QR. From the question, we have been given the vector PQ and the vector RQ. Vector QR is equal to negative of the vector RQ. We can see from what we have here that PR is equal to PQ plus QR. But in the question, we have RQ. And we have seen that the vector QR is equal to negative of the vector RQ. So it means that we can replace the vector QR with negative RQ. And so when we do that, we will have PR is equal to PQ minus RQ. Now we can substitute what we have here into this to get the vector PR. So when we do that, the vector PR will be equal to the vector PQ, which is 2, 4, minus the vector RQ, which is negative 1, 5. 2 minus negative 1 will give us 3, and 4 minus negative 5 will give us negative 1. So it means that the vector PR is 3, negative 1. When we look through the options here, the correct option is option B, 3, negative 1. Vector OA is 3, 5, and vector AB is 1, 4. If O is the origin, find the vector OB. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. The vector AB is equal to the position vector of B, which is given by the vector OB, minus the position vector of A, which is given by the vector OA. We have the vector AB as 1, 4, and the vector OA as 3, 5. So we can substitute it here and find the vector OB. The vector AB is 1, 4, and the vector OA is 3, 5. So you have 1, 4 is equal to the vector OB minus 3, 5. So the vector OB will be equal to 1, 4 plus 3, 5. 1 plus 3 will give us 4. 4 plus 5 will give us 9. And so the vector OB is equal to 4, 9. When we look through the options, we can see that the correct option is A. If vector A has the components 2, 4, and vector B has the components negative 2, 6, find vector C such that vector C is equal to 2A plus B. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. Vector C is equal to 2A plus B. We have the components of vector A and vector B, so we can substitute them into this equation to get the components of vector C. The components of vector A are 2, 4, and the components of vector B are negative 2, 6. So vector C is equal to 2 times 2, 4 plus negative 2, 6. 2 times 2 will give us 4. 2 times 4 will give us 8. So vector C will be equal to 4, 8 plus negative 2, 6. 4 plus negative 2 will give us 2, and 8 plus 6 will give us 14. So the components of vector C are 2, 14. When we look through the options, we can see that the correct option is C. Find the length of vector negative 5, 10. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. We are going to find the length of this vector. If you have a vector, let's say vector A, and it has the components x, y, the length of this vector, or the magnitude of this vector, is equal to square root of the square of the x component plus the square of the y component. So if we apply that here, then the length of this vector, or the magnitude of this vector, is equal to square root of the square of the x component. The x component is negative 5, so negative 5 squared plus the square of the y component. The y component is 10, so 10 squared. This will give us square root of negative 5 squared is 25. 10 squared is 100. And this is equal to square root of 125. When we reduce square root of 125 to its simplest form, we are going to have 5 root 5. So the length of this vector is 5 root 5. When we look through the options, we can see that the correct option is C. Express 30 kilometers 240 degrees in the form of AB. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. We have the vector 30 kilometers 240 degrees in the magnitude direction form, and the question wants us to express it in the component form. If you have a vector in the magnitude direction form, for example, if the magnitude is r kilometers and the direction is theta degrees, and you want to express it in the component form, the x component will be r sine theta and the y component will be r cos theta. So if we apply this here, then we can say that the vector 30 kilometers 240 degrees, if we express it in the component form, we are going to have 30 sine 240 degrees as the x component and 30 cos 240 degrees as the y component. 30 sine 240 degrees will give us negative 25.98, and 30 cos 240 degrees will give us negative 15.00. So when we express the vector 30 kilometers 240 degrees in the component form, we are going to have negative 25.98 as the x component and negative 15.00 as the y component. When we look through the options, we can see that the correct option is A. If Q is equal to negative 4, 2, find P such that Q is equal to half of P. This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. The equation given to us is Q is equal to half of P. We are going to find P, so let's make P the subject. To make P the subject, I'll multiply both sides by 2. When I multiply both sides by 2, you can see that 2 and 2 will cancel. And so we will have 2Q is equal to P. The question tells us that Q is equal to negative 4, 2. So we can replace Q here with negative 4, 2. When we do that, we are going to have 2 times negative 4, 2 is equal to P. 2 times negative 4 give us negative 8, and 2 times 2 give us 4. So you have P is equal to negative 8, 4. When we look through the options, we can see that the correct option is D. Which of the following vector is parallel to the vector negative 4, 3? This is a multiple choice question, and so we will solve the question, and after that we will pick the correct option. We are looking for the vector that is parallel to the vector negative 4, 3. If two vectors are parallel to each other, then one is a scalar multiple of the other. So if two vectors are parallel, it means that one vector is a scalar multiple of the other. The vector given to us is negative 4, 3. So among the 4 options here, we are looking for the vector that is a scalar multiple of negative 4, 3. When we look through them, we can see that if we multiply negative 4, 3 by 2, we are going to get negative 8, 6. Because 2 times negative 4 will give us negative 8, and 2 times 3 will give us 6. So it means that negative 8, 6 is a scalar multiple of negative 4, 3. And because negative 8, 6 is a scalar multiple of negative 4, 3, we can say that negative 4, 3 is parallel to negative 8, 6. So among the options given to us here, the vector that is parallel to negative 4, 3 is negative 8, 6. This is because it is a scalar multiple of negative 4, 3. So the correct option is C, negative 8, 6. This is a multiple choice question, and so we solve the question, and after that we pick the correct option. We have vector OP and vector OQ. Both of them have been given to us in the magnitude bearing form. The magnitude of vector OP is 7 meters and the bearing is 140 degrees. And the magnitude of vector OQ is 4 meters and the bearing is 50 degrees. If you have a vector in the magnitude bearing form and you want to convert it to the component form, if the magnitude is r kilometers and the bearing is theta, when you convert it to the component form, you are going to have r sine theta as the x component and r cos theta as the y component. So here, if you want to convert the vector OP, which has a magnitude of 7 meters and a direction of 140 degrees to the component form, the x component is going to be 7 sine 140 degrees. So the magnitude sine the direction will be the x component. And then the y component will be 7 cos 140 degrees. The magnitude, which is 7, cos the direction, which is 140 degrees. This will give us 4.50 as the x component, and the y component is negative 5.36. We will do the same thing for vector QR. So when we convert vector QR to the component form, the x component will be 4 sine 50 degrees as the x component, and then the y component will be 4 cos 50 degrees. 4 sine 50 degrees will give us 3.06, and 4 cos 50 degrees will give us 2.57. So we have converted vector OP and vector OQ from the magnitude bearing form to the component form. The question says that we should find the bearing of P from Q. The bearing of P from Q is the bearing of the vector QP. So we first have to find the vector QP. The vector QP is equal to the position vector of P, which is the same as the vector OP, minus the position vector of Q, which is the same as the vector OQ. We have the components of vector OP and the components of vector OQ, so we can find vector QP. 4.50 minus 3.06 will give us 1.44. And negative 5.36 minus 2.57 will give us negative 7.93. So it means that the vector KOP is giving us 1.44 as the x component and negative 7.93 as the y component. We are going to find the bearing or the direction of this vector. Let's draw our simple xy plane. We know that the positive values of x will be here, the negative values of x will be here, the positive values of y will be here, and the negative values of y will be here. The component of KOP is 1.44, then negative 7.93. The 1.44 means that the x component is positive, and the distance is 1.44. So we have 1.44 in the positive direction of x. And the y component is negative 7.93, which means that the y component is negative. If it's negative, it means that it will come to the negative portion of y. And the distance is 7.93. So 7.93 in the negative portion of y. That is what we have here. We are looking for the bearing of P from Q. So it means the starting point is Q and the ending point is P. The bearing of P from Q will give us the total angle here, the angle from this point up to this point. But we know that the angle from here to here is 90 degrees. The angle we have here is 90 degrees. So it means that what we need is the angle here, because if we're able to find this angle, which I've represented as theta, and we add it to 90 degrees, we will get the bearing of P from Q. So let's find the angle theta here. We know that the distance from this point to this point is 1.44, and the distance from this point to this point is 7.93. So it means from here to here is also 7.93. What we have here is a right-angled triangle. 7.93 is opposite to theta, and 1.44 is adjacent to theta. So we have opposite and adjacent. We can use tan to find theta. So tan theta is equal to the opposite side, which is 7.93, divided by the adjacent side, which is 1.44. We'll get theta by finding the tan inverse of 7.93 divided by 1.44. Tan inverse of 7.93 divided by 1.44 will give us 79.7 degrees. So the value of theta is 79.7 degrees. As I've already indicated, the bearing of P from Q is the total angle here. We have seen that the one here is 90 degrees, and we have just found out that theta is 79.7 degrees. So the bearing of P from Q will be equal to the 90 degrees plus theta, which is 79.7 degrees. And this will give us 169.7 degrees. Remember, the question said we should correct our answer to the nearest degree. If we correct 169.7 degrees to the nearest degree, we are going to have 170 degrees. So the bearing of P from Q is 170 degrees. When you look through the options given to us, we can see that the correct one is B. Vector P is equal to 1, 2. Vector Q is equal to negative 2, 3. And vector R is equal to 1, 1. Evaluate 2P minus Q plus R. This is a multiple choice question. So you solve the question, and after that you pick the correct option. 2P minus Q plus R will be equal to 2 times P. P is 1, 2. So 2 times 1, 2. Minus Q, Q is negative 2, 3, plus R, which is 1, 1. 2 times 1 will give us 2, 2 times 2 will give us 4. So you have 2, 4 minus negative 2, 3, plus 1, 1. 2 minus negative 2 plus 1 will give us 5. 4 minus 3 plus 1 will give us 2. So it means that 2P minus Q plus R will give us 5, 2. When you look through the options given, see that the correct one is D.